Good morning, everyone, and good afternoon to those of you who are joining us from different time zones. It's 10 o'clock here in Lomita, California, so I'd say it's about time to get started. I'd like to welcome you all to my webinar on signal conditioners, voltage attenuators, and current transformers. I'd like to thank you all for taking some time out of your Friday to spend with me. In this presentation, I hope to explain the function and applications of some of our lesser-known products, all of which are used to translate sensor signals into acquirable data. Let's look at our agenda for today. We're going to learn some basic terminology and definitions for each type of product. Then we'll look at application examples for all those products before moving on to individual product specs and product examples. And as always, we'll wrap up with our Q&A session. I have Robert, one of our application engineers, on the call with me today, and he's here to answer any of your more technical questions. I do ask that you hold your questions until the very end, but if you think of something during the presentation, feel free to type it into the Q&A box through your Zoom toolbar, and we'll get to those on a first-come, first-served basis at the end. If you have a microphone and would prefer to ask your question on the air, just raise your hand during the Q&A, and we'll try to get to you. First, a little bit about us. ICP DAS was founded in 1993. Our headquarters is located in Hsinchu, Taiwan. ICP DAS USA was launched in 2001 to support the North and South American markets. We have over 150 R&D engineers working to support our customers and develop new products. All of our products are RoHS compliant. We are ISO 9001 certified in the States, SGS certified in the UK, and we're a Windows embedded partner. So let's get to the basic terminology and definitions. Signal conditioners, voltage attenuators, and current transformers are similar products that each serve a unique function in your data acquisition system. All of them could be called an intermediary device between a sensor and a data acquisition module. The signal conditioners, for example, take strain gauge or thermocouple input and translate it into an analog voltage or current range that you can acquire with a wide variety of analog input data acquisition modules. This eliminates the need for a specialized type of input module, one that only accepts input from one type of sensor. This is especially useful if you're adding new sensors to an existing DAQ system, and maybe you have some input channels left over from the original design or an earlier expansion. Instead of buying and installing a new data acquisition module for your new sensors, you can translate those signals into an input that they already understand. Signal conditioners, and most of these products actually, provide the very important function of removing signal noise by isolating your sensor input. This is especially important in a high interference environment and when you're measuring high power circuits. Voltage attenuators perform a similar function. They are made to measure very high voltages by stepping those voltages down to a level where they can be read by an analog input DAQ module. Our DN and DNM series modules have a maximum input voltage of plus or minus 600 volts, which can then be attenuated down to plus or minus 10 volts. Finally, there are current transformers, which are sensors which produce an alternating current output in proportion to the current flowing, they produce an AC voltage in proportion to the current flowing through the primary winding. Current transformers wrap around an electrical conductor, usually a power cable, and output an AC voltage in proportion to the current flowing through that conductor. The primary winding, the loop around the conductor, usually consists of a single flat turn and never more than a few turns, whereas the secondary winding consists of many turns around the primary. And this steps the current down from a very high amperage to a voltage value in a known ratio. So, when to use a signal conditioner? A signal conditioner is a great solution for an application where it would be impractical to use a DAQ module with specialized inputs. It provides a specific interface to a particular sensor, providing the proper excitation, scaling, and buffering. For example, RTDs require a constant current source, and strain gauges need a constant voltage source, whereas thermocouples don't need an external source, but they do need compensation for unintentional cold junctions. Our signal conditioners provide the specific requirements you need to get accurate measurements for different sensor types, including different types of thermocouple, RTD, strain gauge, irregular DC voltage and current input, and triaxial accelerometer input. Our signal conditioners provide three-way isolation. It's isolation on the power, communication, and channel-to-channel. Isolation is especially important in high-noise environments and when you're dealing with very high voltages and currents. When to use a voltage attenuator. You use a voltage attenuator to step a high voltage down to a proportionally lower voltage at a known ratio. The most common type of attenuator would actually be the volume control on your radio, one you might be most familiar with. You take a strong signal and step it down to a proportionally weaker one. That type of attenuator is called a variable attenuator. You can attenuate down to a variable amount. Our voltage attenuators are passive attenuators with a linear attenuation ratio. The circuit diagram shows a very simple voltage attenuator, a 4-terminal, 2-port passive resistive network that sends the source voltage through a passive resistor circuit. And current transformers. Our current transformers transform an input current into a readable output voltage. They always work in conjunction with another sensor module, like one of our DN and DNM series voltage attenuators, or with one of our smart power meter modules. The primary winding replicates current from the power source, and the secondary winding produces a proportional AC voltage. You use a CT in conjunction with another module or sensor to take power readings from machinery in use. Our PM3000 series power meters, for instance, measure a wide range of voltages and currents, usually using one of our split-core CTs. While we're speaking about CTs, I want to show you the 3 types of CT that we sell. These are solid core, split core, and Rogowski coil CTs. The solid core aren't usually sold separately, not in our products, but instead are integrated into the circuitry of a current sensing and voltage attenuating module. The power line is fed through the solid loop of this CT. Split-core CTs have a hinge that allows the loop to open and fit around a power cable. A split-core CT should never be fitted to a live current. Leaving the current open during operation can result in damage to the module or injury to operators. And finally, we sell Rogowski coil CTs. This is a flexible coil that is wound around a power cable. Our solid core CTs are used to transform relatively low currents, whereas Rogowski coils are used to transform the highest currents, with our split core clip-on CTs used to measure a wide range of voltages and currents in between. Let's look at a couple quick applications. This is a current sensing application using our DN and DNM series. The DN series module here measures voltage and current coming from power inverters in this wind and solar application. The solid core CTs transform the current into a readable voltage, and the voltage attenuating channel tunes the voltage down to a level readable by our i7000 series data acquisition module. The reading is communicated to one of our standard analog input modules, which can then transfer that data to the control room or SCADA to calculate and log power output. So for a current sensing and voltage attenuating application, the DN and DNM series, or actually the DN831i 600V to 2000 amp is a one-channel voltage attenuator and one-channel current transformer. The maximum voltage input range is from plus or minus 600 volts, which can be attenuated to plus or minus 10 volts, and the maximum current input range is from plus or minus 2000 amps, which can be attenuated to plus or minus 10 volts. Provides 3000 volt DC intramodule isolation and 3000 volt DC channel-to-channel isolation to avoid interference from inputs to outputs or from channel to channel. And it can be used along with analog input modules such as our I7017, I87017, M7017, etc. To measure high currents. And in this application, the DN series module can monitor power consumption from the golf cart's battery as it charges, and with enough sensors, you can keep a live tracking system that will tell you when each cart in the fleet is done charging and which carts need more time. So let's talk a little bit about our selection. The SG3000 series is our selection of signal conditioners. The SG3011 is a thermocouple input signal conditioner. SG3011 uses microprocessor-controlled high-resolution 24-bit dual slope, integrating the AD converter to acquire thermocouple signals and compensate for cold junctions. Temperature measurement is handled by thermocouple linearization and cold junction compensation function. Supported thermocouple types are J, K, T, E, R, S, B, N, C, L, M, and L2. The SG3016. Oh, and I do apologize for that slide. Looks like the picture is over the letters. The SG3016 is a strain gauge input to voltage or current output signal conditioning module. It has 3000 volt DC three-way isolation for input, output, and power. Users can change the input and output range via internal configuration switches. The SG3016 has an LED display to show whether the SG3016 is functioning correctly, and it has 3 VRs, 0 span and XI, to calibrate the input and output range accuracy. The bandwidth of the SG3016 is typically 600 Hz, and it's easy to mount the SG3016 on a standard DIN rail, and it can operate within a wide temperature range. Just to give you an idea of the type of signal conditioners we have, you can see our selection table. So as I mentioned before, the 3011 and the 3016, that would be our thermocouple and strain gauge input modules. But we also have the high-speed sampling thermocouple module, RTD input, as well as triaxial input. And we also have DC voltage input and output for irregular DC voltages. And we also have DC to DC power modules. And this family also includes surge protectors and termination resistors. So I spoke a little bit before about our DN and DNM series. Let's just talk about it briefly. The top module there, the DN843i CT-10, is a 3-channel 10-amp current input sensor with channel-to-channel isolation. The maximum input range for this device is from plus or minus 1 amp to plus or minus 50 amps, which can be attenuated to plus or minus 1.6 volts to plus or minus 10 volts. The I version provides 3000 volt DC intermodule isolation and 3000 volt DC channel-to-channel isolation to avoid noise interference from input to output or from channel to channel. And this can be used with our analog input modules such as I7017. The bottom module, the DN831i 100 volt 50 amp, is a one-channel voltage attenuator and one-channel current transformer. So the sensing module that provides both. The maximum voltage input range is from plus or minus 100 volts, which can be attenuated down to plus or minus 10 volts. And the maximum current input range is from plus or minus 50 amps, which can be again attenuated to plus or minus 10 volts. It provides 3000 volt DC intramodule isolation and 3000 volt channel to channel isolation to avoid noise interference. Again, this can be used with our analog input modules such as the I7017 or the M7017. And just to give you an idea of what we have available, this is the DN and DNM series selection table. The difference between DN and DNM is just that the DNM modules have a metal housing. But you can see these come in current transformer versions, voltage attenuator versions, and versions which measure both. And in the past, I've spoken a lot about our PM3000 series, so I won't get into too much detail here. If you have more questions about it, you can, of course, email me. And we do have all of our past webinars available on our YouTube channel, so I can easily send you a link if you would like to learn a little bit more about our smart power meters. But I did mention our Rogowski coil, so I wanted to give you an example of a module that uses the Rogowski coil CT. This is the PM3133 RCT. This gives you access to real-time electric usage for three-phase power measurement. This module enables the users to obtain reliable and accurate energy consumption readings from monitored equipment in real time. These compact and cost-effective power meters use the Rogowski coil rope-style current transformer, which makes installation easy with a large window size for 55 to 185 millimeters, and mechanical flexibility if you're operating in tight spaces. It operates over a wide range of input voltages, 10 to 500 volts AC, which allows for universal compatibility. Also, it provides 2-channel relay output, so you can link it with sirens or lights for easy alarm messages. These modules support Modbus RTU, Modbus TCP, or CAN Open for easy integration with your data acquisition and SCADA network. So that about wraps it up. Now that we've had a look at our products, some of their applications, gone over basic terminology and functions for all three types of devices, I'll just summarize the benefits of each. While each type of product produces a similar outcome, that is, changing an input into a readable output, they all have their own unique applications. Signal conditioners are a great fix for adding sensor capability to an existing DAQ system. They're also great for high noise situations and in applications where you don't need a specialized DAQ module. Voltage attenuators step voltage down to an acquirable level, in our case using a fixed linear ratio. And CTs are a sensor used to read operational current without needing to tap into a power line. They communicate with our current sensing modules and with the voltage attenuating modules in the DN and DNM series, as well as with our smart power meters. As always, why should you choose ICP DAS USA? Besides the benefits you've seen here, we manufacture a large selection of data acquisition and industrial control products that are all reliable, cost-effective, and they work well with third-party components. But that about brings us to the end of this presentation. I hope you learned something. I'm just going to put our contact information up on the screen. If you have any questions or would like to see a copy of today's presentation, you want to see the slides, or for me to send you the video when that's available in a couple days, I'll leave the contact info up during our Q&A session. So now we're going to move into the Q&A session. Like I said, I have Robert, our application engineer, here on the phone with me. He can answer any of your more technical questions. And we're going to get to the Q&A box questions in sort of a first-come, first-served basis. Then we'll open the floor up to you. You can raise your hand if you have a mic.